What is statics? Oh, yeah. So what is statics? Stats is a field of collection, analyzing and presentation of data. That is a statistic. Okay, like you can say, to get more information about your table and data. Understanding your data is a statistic with the help of number. Okay, we do some calculations, we get some output. According to that, we will understand our data. So that is a statistic. So how many types of statistic we have? Basically, we have two types of statistics. Okay, first is this one descriptive stats, and second is inferential. And what about descriptive statistics? What is it? We can say descriptive statistics helps organize, analyze, and present data in a meaningful way. It summarizes and describes the main feature of the data set, such as mean, median, mode, standard deviation, to provide a quick overview. Descriptive stats can include sorting and grouping, illustration, summary statistics, measures of the dispersion, and many more. Okay, and what about the inferential? What is it? Inferential stats use sample data to make estimates. Descriptive help organize, analyze, and present data in a meaningful way. And this one, inferential statistics, use sample data to make estimate, prediction. So you can understand like this is for like presenting the data, and this is for making the prediction. Okay, so like you can understand this is for analysis, and this one is for machine learning. or other generalization about a larger population. It involves using probability theory to infer characteristics of the population from which the sample was drawn. Inferential strats can include comparing data, making prediction and hypothesis, and testing hypothesis. For example, a t-test is an inferential stats that determines if there is a significant difference between the means of two groups. Okay, we'll talk about t-test, j-test later on. First of all, here we can see a term which is used, that is, we can say the population. What is the population? Okay, anybody knows what is the population here? And let me tell you, it is not about the population like this one. Okay, somebody entire data. Subina. Yes, correct. Entire data, that is the population. So basically, we have to be very careful when we are taking the data and sample. Not careful, but we have to be very serious one. Population here, we will be taking the whole data for doing statistics. For example, if we have to find the mean height, and then we're gonna take data of that of the state, of the particular state and country, you can say. See, usually what happens, suppose you got a work that you have to find the mean of the entire world. Okay, you have to find the mean of the entire world, and this is your entire world. You have to find the mean of this. Okay, this is your world, and there is many countries here, right? So basically, what we will do, if we have to find the average height of this universe, we will not be taking the data from all the countries. We will be taking the data from only a few portion. Okay, we'll use only a few portion of the country to pull out the data, and then we will find out the mean. What is the reason behind it? Why we are not calculating the data from all the universe? Any reason for that? Any answers? The mean of the sample is equal to the population mean. Mm-hmm. Basically, it is not equal, but we assume it to be equal. equal to the population mean. So parameters can be find for the population with the help of sample. Yeah, basically, see, cost, we have to put a lot of cost to calculate to collect the data from all the countries, right? So that's why we take only small portion of sample from one of the states. See, there is only this is not the only process. There is lot of process. Like either you can take it from one of the states, one of the countries, or either you can take small samples from each state. All right. So there is various steps to take it. There is not only one way. I will also talk about it, like how to collect the data. The main thing is about the cost. Cost is too much if you keep on collecting the right. Okay. Just 1 minute. Let me so there is two types of collection of the data that we can say. First is random, and then we call it random and systematic sampling. So first is random sampling, right? And second is we can say systematic sampling. Can anybody anticipate like what is random? See, random is very easy. What is systematic sampling? Sampling vary every ith number means. Okay. So let me first talk about the random sampling. See, if we are doing data science, it is very necessary that we should be very good at the statics, right? Otherwise, we will not able to understand our data. Statics and some test hypothesis and all these are very necessary. Even for data analytics also, it is very important. Select element in some order, sequence or interval. Yes, that is fine. See this. Random sampling. What is the meaning of random sampling? So each sample has an equal probability of being selected. This is random sampling. And the samples are selected one at a time. This method is simple and straightforward, and it's free from personal bias. Random sampling is best for smaller data sets and can produce more representative results. It can be done using tables of random numbers or electronic number generator. As we know, it's very easy, right? So like we can directly get our data from anywhere. It's like it's like probability sampling method. Yes. So all the data is equally. Suppose we have four portion in the world. All the data is having the same probability, 1/4, 1/4, 1/4, every data, right? That's why it is saying that every data is equally probable. It's not biased, free from bias. Okay, now let's come to the topic of system systematic sampling. Hmm. Okay, so systematic, what we have systematic. How to do the full screen for this? Uh, Full screen for this. All right. Samples are selected at predetermined intervals. Samples are selected at predetermined intervals, and the probability of being selected is not equal. Here, the probabilities varies a little bit. Probability varies for each sample, and we can see we have intervals also. A systematic sampling is easier to execute than random sampling, and it can be beneficial when the population is large, diverse, and hard to reach. However, it can produce skewed result. Your data set has pattern, and it can be more easily manipulated. Skewed means it could be your data could not be a normal distribution. It could be like you can say a little bit of skewness you can see. Wait, this is still not like this. This is skewness. For example, if students are seated in a repeating patterns such as boy, girl, and the sampling interval is an even number, the sample could end up with all the boys or the girls. To avoid this, you can sort the data to remove the repeating patterns, right? It's very, if you are having all the girl, boys, girl, if you are selecting only the even number, you will end up getting all the boys. So you will miss up the girls. So it's better to avoid this. You can sort the data to remove repeating the pattern. All right. Then we have sample. So the definition of sample. What is sample? In here, we will not take data of complete state. We will just take some sample out of it and do statics over it. So as I already told you that population means taking the data of complete state, complete world, you can say. K is equals to n by n. What is this? What this is the formula for what one? What? Sample. This is your world, and sampling means, yes. So we will just take a little few data and we'll assume this that this is the data of complete universe. All of the operations we will perform over this only. N is the whole population. Hmm. N is sample wise. In the chat it is saying. Fine, okay. In a simple term, this is sample, okay. So it is cost efficient also, you can say. So you don't have to spend a lot of money to collect the data, right? Sampling. So we'll get some samples only. Okay, give me some real-time examples of these sampling. For example, suppose you are working as a in a product companies, and there is a lot of, it's a biscuit company, okay, and it was found out that suppose Maggie biscuits, anything, right? And it's found that your product is having high number of sodium, high amount of sodium, or anything which is not good for health. So in that scenario, what you will do? You will collect whole Maggie packets, or you will select the few only. So what is your opinion on that? This is a real time. This is a real example I'm telling you. Few packets of Maggie, right? Correct. We will take few packets of Maggi, and we'll assume that this 10 packets. I will take 10 packets is presenting the whole warehouse. Yes, it is presenting the whole warehouse. Few random packets. Yes, correct. Mm, sampling. See this graph, right? What do we see over here? So here we can easily see here population is there, right? So we can easily see this is the complete population and this is our sample. So sampling means pulling out few information from our complete population. So there is various way of doing the sampling. Let me tell you. You can see. So here we have simple random. This is an example of simple random sampling. This is systematic. Like you are skipping some, uh, you are jumping some of the intervals. Stratified. What is the meaning of stratified sampling? What is stratified sampling? Researchers divide subjects into subgroups called strata based on characteristics that they share. It could be race, gender, education, attainment. Once divided, each subgroup is randomly sampled using another probability sampling method. So first of all, you'll divide your complete population in subgroups, small parts, and then you will be taking uh, the data from there. So what is the real life example of this? Of What is a real life example of this stratified? Just one minute. Example. To study how income varies by educational attainment, but also consider how race might affect their relationship. You can use stratified sampling to ensure that each racial group is represented in large enough numbers to draw more precision con- conclusion, right? So like you can understand that to understand like how the race of people, like you can say African, American, Asian. First of all, divide them in the different part: African, American, Asian, and then you can like do the sampling and find out their income, right? So we can easily figure out that some race is earning less. So this is how we can figure out from this. Okay, is there any other example of this? You people are open to do Google and all this, and just tell me some real example of this stratified. Yeah, what is example? Yeah, okay. One grouping like age-wise, female or male. Yes, that is correct. But for doing what kind of sampling? Like there must be a aim to do that, right? But you just mentioned the factors which we are dividing our data, but for what purpose? Taking survey from for the insurance we can use, but taking the insurance is from the random public, right? There is no stratified making strata of incomes. Okay, according to the income. Yes. According to the income, you can make the group. Yes, that is fine. Considering stratified sampling to understand academic performance of different high school of certain city. Yeah, that is fine. Like only high school student, yeah, this could be a feature of doing stratified sampling. Okay, see, there is one more. You can see over here, clustering. What is clustering? Let me tell you before we move forward. What is cluster? Cluster sampling is a probability sampling method in which you divide a population into clusters. Anybody please tell me what is clusters? Yeah, what is clusters? Which are close to each other. Yeah, in terms of feature or characteristics, they're alike. They are similar. So it is a group of people which are similar. Not people, it could be anything. It could be product or anything, but it is similar. Which are close to each other, a bunch of groups. Yes, suppose if I do the clustering of the traffic, then I will be making group of all the cars together, all the buses together, and all the three-wheelers together. So that is called a clustering. Okay, such as district or schools, and then randomly select some of these clusters as your sample. The clusters should ideally each be mini representation of the population as whole. See, this is different with the stratified and cluster, right? In stratified, we were making the groups, but that was according to characteristics that they share, like uh, race, gender, education, attainment, right? But in the clusters, we are making them in a single group. I will also do the difference between them because they are almost same cluster. Some real life example of clustering is we can say market research. A company might divide its customer base into cluster based on the age, gender, or location, and then select a random sample from each cluster to better understand their preferences. But here we were dividing the races to know their incomes difference. And here we are doing market research according to the age, gender, and location. Because it is easy to divide large data set. Fine. See, both of them are looking almost same. I think this example will make difference. You can see over here this one. Stratified. On the left hand side, we have stratified. Okay, where first of all we were making groups of similar kind of data, and then we are pulling out the random value. There is huge difference if you see. Let me also write it here. Uh, uh, wait, what I just can anybody like tell me what is a huge difference between both of them? There should be a heterogeneity heterogeneity within clusters and homogeneity between clusters, and then we select clusters randomly. See, first of all, what happens? Okay, let me write this in the new. We have to understand the difference between both, and difference is very clear from this. In stratified, what we do, first step is in stratified is group alike, alike data, right? And then second is choose random data from them. Yeah, then we choose random data from all of the cluster. But here in cluster, it is different. It is reverse. You choose random data, random groups. Like a it could be random because they are getting clustered, and then choosing the complete whole group, not random. You will not choose a random one. Now you complete uh, choose group. There is little bit different, but you have to understand. There is only the steps are getting interchanged. Robin Singh, have you joined from the mobile? I think it will be more clear by this example. This is stratified. First of all, you are making alike groups, and then you choosing the random from these one. Like this one is selected, this one is selected, this one is selected, right? And but in clustering, what you do, you select the randoms and then make the group, and then select particular groups only. So there is only difference between, there is a difference of steps. You just have to understand that. Okay, next thing is we will be talking about random variables. What is random variable? A random variable, a random variable, we can say, is a numerical description of the outcome of a statistical experiment. A random variable that may assume only a finite number or an infinite sequence of values is said to be discrete. One that may assume any value in some interval or real number line is said to be continuous. I will talk about this discrete and continuous. But first we need to know that what is random variables. See, if we are performing some kind of experiment, then we can have some variables, random variables. For example, if we are performing the toss, right? It could be head, it could be tail. That is a particular random event. A possible value could be 0 or 1. 1 for head, 0 for tail. But there is only one random variable, which is x, which can contain either head or tail, right? That is a random variable. So if you are collecting the height of the population, then there is only one random variable, which is height. If you are collecting income, race, both, then how many random variables we have? Uh-uh. You can answer in chat. 21 student and zero answer. Still no answer. What happened? The topic is getting too difficult or what? Why would you please repeat would you please repeat the question? Pardon sir, can you repeat the question? See, this is what happens when we do not pay attention. The question was, if the question is, if we are collecting the race and income both, then how many random variables we have? There will be two random variables, one for race, one for income. Yes, correct. This is the answer. Uh-oh. Okay, next topic will be our discrete random variables and continuous random variables. And then we will do categorical random variables and all that. All right, so our next topic will be all these, and then covariance, correlation, Pearson correlation, central limit theorem, Chebyshev, Spearman rank correlation, Z score, interquartile range. Yes, all these will be our next topic. So be prepared on. All right, have a good day.
Can I wind up the session, sir?
Yes, it's almost done.
Okay, sir. Thank you so much.
Welcome.